Good morning, class. Today, I'm going to try to sort of review a little bit of what I went over yesterday. And what's funny is I can tell you learning this even in person is often a little bit awkward just because using your right hand and directions and all that. And then now doing this via video makes it even an extra layer of a challenge. So today, I'm going to try to walk us through what I went over yesterday and maybe give a little bit more visual explanation. And also, you'll notice I basically put, they're technically 4 assignments on Google Classroom, but each one is a very straightforward problem. And I'll walk you through how to complete those as well. But to kind of review, yesterday I introduced right hand rule number one. And this is talking about whenever you have current traveling in a straight section of wire, and apparently it's going to make that wire slightly magnetic, but the direction of your magnetic field, it's a very weird, awkward, circular kind of magnetic field that just kind of continuously goes around in that circle, which, trust me, it's a little hard to visualize and it's pretty normal, so don't worry about it if that's the case. But just to give you a little bit of practice on how to illustrate this and apply the right hand rule, I know yesterday I kind of went and I flipped my screen one side to the other. But another way that I often show this in class, it's kind of easier to do it from your perspective. So, kind of like if you have a piece of paper in front of you, I have to like make sure. Okay, wait. All right. Notice this is my right hand. This is just as if you were sitting there and you have a piece of paper in front of you. Now, if I were to say, hey, there's a piece of wire that is traveling, current is traveling that direction. What is the direction of my magnetic field? You would use your right hand, thumbs up gesture, always positive. And then you would simply go, okay, have the thumb go that direction. And you're going to notice your right hand, your fingers curl in the direction, the natural way that your fingers can curl. That's the direction of the magnetic field. So if I were to draw this quickly on paper, and I'm doing this on paper because at first I was trying to find ways of using, there's a lot of applications that we have possible. If you haven't ever browsed, actually, let me go here. Screencast, get out of my way. Of course, screencast is in my way. There is for those of you that haven't browsed too much of the functions that we have, one that I actually got released is called Sketchpad. And I was considering trying to use this to teach how to do illustrations of right hand rule, but I would have to spend a lot more time kind of practicing with Sketchpad. But I'll tell you, if you're bored at home, I think I showed you guys this way early in the year. Again, you can go and draw some cool spirograph art and other things, but let me see, pen. I think I've done some sort of function right now that's making it overlap. Either way, I'm not going to teach it like this. I'm more old fashioned. You guys know me. So, pen and paper, easiest way. I'm going to quickly illustrate. All right. So, all right. If I had a wire and current was traveling that direction, what is the direction of the magnetic field that's acting? Well, get your right hand, thumbs up, have your thumb go the direction of the magnetic field, and notice your fingers are going to curl that direction. And I often say it's kind of like holding a pen, helps you kind of visualize what's happening. Notice on top of the pen, my fingers are coming out of the page or out of the screen. On the bottom of the pen, your fingers are going into the page or into the screen. And that's why yesterday the X's and O's, they came into play, which I am not going to play again. It got stuck in my head yesterday. Maybe it got stuck in your head too. If that's the case, I apologize. But what you would draw if you had to illustrate the magnetic field would be X's and O's. Notice if you use a right hand, all right, notice on top, your fingers are coming out of the page, out of the screen. And on the bottom of the page, they're going, hey, into, and that means the X's. So this is how you would illustrate this. But if you looked at today's practice problems, you'll notice that I have the wire drawn from a different perspective. So let's say if I'm holding my wire, okay, right now the current is going from one side to the other, but what if the wire was held along this direction, kind of in or out of the screen? Or you can picture it as if this is a really long wire going kind of either in or out of the screen. How this would be illustrated, this is my wire. And again, I'm kind of looking at this from the perspective of it's either going in or out of the screen. And let's say if I tell you the current is going, okay, now this is where it gets awkward using the camera. Let's say that it is traveling into the paper. Into the paper, I would illustrate that with which variable or which letter? X. And X would mean the current is traveling into the paper. And if I had to draw my magnetic field, right hand rule, thumbs up gesture, thumb goes, I'm terrible. There we go. Thumb goes into the paper. And which way are these four fingers curling? Well, magnetic field, it looks like it's going to go in this clockwise direction. Simple as that. Clockwise, no need to draw anything else. That is clear enough. And then what if instead I have a wire? And again, this bottom wire is basically kind of, going along this direction, but the circle inside, the O, means the current is traveling out of the page. And out of the page means coming out towards you. Again, I cannot aim very well with this Chromebook. So, right hand rule, which way is the current traveling? Your thumb should point out of the screen or out of the paper. Therefore, which is the direction of the magnetic field? Notice these fingers are going to curl naturally counterclockwise direction. And hey, that's all you have to illustrate right there. So this is meant to be more as like a little introductory lesson, not just on using right hand rule and also how to get Sharpie on your hand because you don't really know what you're doing. But there's also another purpose for today, a little bit of practice for you and for me. Originally, if we were in class, I would have printed out and given you guys this worksheet right here. And, I would basically say, hey, do this, draw on this. And it would be so much easier to do this if we had paper in front of us and we could just show me, I could stamp it, no problem. Now, the solution that I've come up with, I didn't even know that we had this add-on within our Google Docs, and basically it's Google Drawings. When I even try to search it, it doesn't quite come up. I accidentally stumbled on it in Help. I just kind of did the word draw, and then, hey, new drawing came available, and it's available for me. I hope it's available for you. So what I've done in Google Classroom, I basically added 4 individual assignments. And literally what I've done is I basically gave you an illustration that I cleverly copy pasted of, hey, just one magnet. And what I've had is the assignment for you guys, nice, straightforward, easy points. But again, I kind of have to give you points for something as we're doing this remote learning. What I'd like you guys to do, you can basically, if you want to be super strict, you can use line. I am kind of lazy, scribble. Again, I don't need precision. And basically just go ahead and let's see, I bet a lot of you guys are going to have fun ways to modify color, this and that. But basically, first of all, what are the internal domain directions? This is the direction or the instructions you see for that first assignment. Come in and let me see, scribble. Okay. Of course, hit Control Z to undo. This worked a minute ago. Scribble. Notice anything that you scribble is going to appear, and again, it's going to be very, very sloppy, but again, I'm not grading for artistic perfection. So the internal domain direction we know is going like this. And then outside, it's going to exit the north and enter in the south. So this is literally what you need to be drawing for our first assignment. Basically, there's four of these I put into Google Classroom. First one is, okay, show right here the internal and external domains for one magnet. Then if you look at the next one, it's for two magnets. How do their internal domains and how do the external magnetic fields interact with each other? Then this is relating to the right-hand rule that I just showed you. Wire one, where, hey, the current is traveling into the page. And then wire two, where the current is traveling out of the page. This is meant to be straightforward. This is really more just practice for you and for me on kind of setting up these more remote learning, as well as quick little kind of double check assignments, if you will. If you have any suggestions on ways that you think this would better work, I like to think I'm very approachable. I'm all ears. So with that, these four assignments, please complete them. You will get credit in Aries. And if you have any questions, email me. The rain's coming down. If you can hear it, hope you're all doing well. Take care.